Okay, so we have this equation, and I'm assuming, I use this equation, I'm assuming that nobody really has much of a clue where this is going, okay? But the one thing that you can do is you can identify the variable, right?
Yeah.
What's the variable here?
Solve for T.
T, yeah. Because, E's not a variable, E's your, limit of 1 plus 1 over n to the nth power, and that goes to infinity. Okay, it's the Euler number, okay? Most important number in mathematics, arguably. As I've said, directly from the Euler number, you get pi without even having to find pi in terms of diameter and circumference of the circle. So it's really a powerful number, and much more than that. Okay, so anyhow, you identify the variable. And mark it. I'm going to mark it with a circle just so I can keep track of where it is. Now, where is that variable that's going to make you have to do some work to isolate it? Because that's really what we want to do. We want to isolate t. There's only one t in the equation, and many times there are 2 or more t's scattered throughout the equation, right? And if they're scattered in the wrong place, you can't even solve the thing. If I put a t here, you can't solve it anymore. All you can do is graph it and understand what the graph is telling you, okay? Which is why we want to tie equation solving in with graphs, okay? And we want to also be able to identify the type of function that we're dealing with. Okay, well, t, why is t hard to, right now, I mean, it's not inaccessible. We're going to easily be able to access t. This really isn't a hard equation to solve, okay? But what's the problem with trying to get to t? There are 2 problems with it. They're not big problems. We know what to do to solve these problems. But
T is the exponent.
It's in the exponent, right? Which means you're eventually going to probably have to do what?
Square root.
Log.
Oh, whatever.
Yeah. It's in an exponent, you're going to have to use a log. Okay? Because that's how you inverse an exponential function, right?
Oh, yeah.
Because we're using an inverse function here. Now, where else is it that's going to be problematic?
Fractional.
I'm sorry?
Where it's a fractional. It's a fraction.
Well, yeah, but more specifically, it's in that denominator, right? Okay? So we got to overcome the fact that it's in a denominator, and also that it's embedded within a function. In this case, the exponential function, right? Okay? So we can't just start off by taking the natural log. Okay? Can you take the natural log of all this stuff? Well, you don't yet know the properties of logarithms. That's one thing we got to wrap up here in the last couple of weeks. They're easy enough. And they're closely related to the properties of exponents. So that's not going to be bad. That's something people, if they take the trouble to practice them a little bit, find actually fairly easy. Okay? But we're not going to do that. We're not going to do that. What's the first thing you think we ought to do here?
Multiply.
I'm sorry?
Multiply.
Multiply what?
1 plus 2e.
Okay, yeah. What you're saying is
Yeah,
we're going to multiply both sides by the denominator, right?
Yeah.
Okay? So, so we can say where is our variable? Well, it could be in a lot of places, right? But the most troublesome place is in a denominator, and it's in an exponent, right?
Yeah.
So we have to deal with both of these things. So when we look at this, we ask ourselves these questions. Okay, when you see an equation, identify the variable and mark it, and ask yourself where it is, because that's going to give you a pretty good clue about what to do about it. Okay? Now we know, the principle is, if we have a denominator and our variable's in the denominator, we probably want to multiply both sides by that denominator. Okay? So what to do about it? Well, we're going to eventually have to do a log because our variable is in the exponent, right? But we're not in the form that allows us to do that. It's got to be the base to a power equals something, right? So we have to get this 2e to the negative 0.07t term isolated on one side with all the other stuff on the other side. So we're not up to the point where we can do that, but if we multiply both sides by the denominator, we'll get there actually pretty quickly and pretty easily. Okay? So, we choose to multiply by the denominator because if we try to do a natural log of both sides, it's not going to do us any good. Okay, so what we do is we say, okay, we're going to have 80 over 1 plus 2e to the negative 0.07t multiplied by 1 plus 2e to the negative 0.07t equals 50 times 1 plus 2e to the negative 0.07t. And, of course, we end up with 80, because, of course, this divided by this is going to give us 1 equals 50 plus 1 times 2 times e to the negative 0.07t. Okay? So we're a lot closer to being able to isolate that e to the negative 0.07t than we were a minute ago. It's no longer in the denominator. It's no longer locked up in the denominator. It's out here where we can do things to it. Okay? So see if you can take the next step.